Prime factors. There's two sides. This side is called factoring to prime factors. Can someone tell me what a prime number is? Raise your hand if you know what a prime number is.
I don't know how to describe it. Well, we use the multiplications to find the number.
Okay, go ahead.
A number that can't be multiplied from one end.
Yeah, a number that can only multiply one in itself. Like the number 3. What two numbers do we multiply to get 3? Well, 1 and 3. So that's a prime factor. Same thing with 7. 7 would be prime because 1 and 7. That's the only thing. 1 and 7. 13. 1 and 13. Those are all prime numbers. Whereas, let's say the number 9. What are two numbers that we can multiply to get 9? 3 and 3. So the prime factors of 9 are 3 and 3. 3 and 3. And that equals 9. Now we're going to do this one. Listen. We're going to use bigger numbers. On the left hand side, 1, 3, 5, 7, so forth. We're going to do those. I'm going to do it in class. I'm going to have you come up here and do it also. For homework, what do you think I'm going to give you?
All the rest. All of them.
One on the other side.
What?
Okay, so let's do 98. Off the top of my head, I know what the biggest number that can go into both of them. But this one is even. 98 is an even number. So we know 98 can be divided by 2. Go ahead and write this down. 98 can be divided by 2 because it's an even number. So this goes into 9 4 times. That's 8. Bring down the 8. That is 4, 5, 6, 7, 9. 9. So if I take the number 98, the two factors are 2 and 49. If I multiply those two numbers together, I get 98. I see right away 2 is a prime, so I circle it. But 49 is not prime. What two numbers can I multiply to get 49? 7 and 7. So I'll break 49 down into 7 and 7. Are those two numbers prime? Yes, 7 is prime. So 1, 2. How many numbers do I have circled? 3. I have 2, 7, and 7. If I multiply all those out, I get 98. So this is the prime factorization. Prime factorization. It should be easy, but when it comes to big numbers, it's a little more complicated. Because some numbers, you don't know if they're prime or not. Just because they end in odd does not mean they're prime. Okay, so 2, 7, and 7. For 83. 83 is not even, so you can't divide by 2. One trick we learned last year. You take the two numbers, 8 and 3. When we add those together, what do we get? 8, 9, 10, 11. That doesn't help us. Try different numbers. Let's try 3. Does 3 go into 83? 4, 3, nope. 2. So 3 goes into 83. 2. That's 6. 13. That goes into that. 4. Nope. Does not go even. What's another number we can use that's prime? Well, we tried 3. 7 maybe? 7, let's try 7. 83 divided by 7. It goes in once. 13, nope. No, because this comes out to 2, it's just not, it's close, but not good enough. There has to be something. Let's try different numbers. Let's try 6. 83. 1, 6, 2, 3. Nope. It's going to have to be something that fixes 3. It could be a prime number. Maybe. Let's try something higher. 33 wouldn't work. How about 13? We're trying higher and higher and higher. 13. How many times does 13 go into 83? 2, 3, 4. Shh. 2, 3, 4, 5, 6, 6. That's 18. 6, 7. Nope. There has to be something else. 17. How many times does 17 go into 23? 2, 4, 6, 8. 4. Let's try 4. 5, 6, 3. Nope, tampoco. This is 5. So this is, the answer is prime. We tried everything, so the answer is prime. We have to keep trying. Once you get to 13, 17, chances are you're out. It's prime. How about 87? Yes.
Why?
Factor. What number is going to 87? Well, it's not, it's odd, so you can't use 2. 8, 9, 10, 11, 12. Okay, 8 plus 7, I took those two numbers, added them together. What does that equal? 15. If the number that they add up to is equal to a number that 3 goes into, then 3 might go into it, the trick. So let's try that. 3 goes into 87. How many times does 3 go into 87? It goes twice here. 6. Bring down. Nope. 3 does not go into 17. Because it's 6, 1, 7. So let's try well, let's do it again. 3 goes into that twice. Shh. This goes in twice here. Oh, 27. Yeah. 27. Does 3 go into 27? Yes. 9. 9 is a prime number. So the prime factorization for 87 is 3 times 29. That's because we added the two numbers together and they add up to something that's divisible by 3. If you do that, then it might work out. So it's 3 times 29. 80. Well, that's divisible by 2, but what's a bigger number we can add it into?
4.
4. 4 and what?
0.
4 and what?
4
How about 8 and 10? 8 and 10. What is it, 4 and 20? Okay, 4 and 20. Are those factors? Are those prime factors?
No.
No. How do we break down 4 into prime factors? 2 and 2. Now we look at 2 and 2. And Nelson, you need to write this down.
Sorry.
2 and 2. Are those numbers prime? So we circle them. Do not forget to circle them. Now we look at 20. What are some factors of 20?
That was it. 4 and 5.
4 and 5.
Sorry,
4 and 5, 2 and 10. I'm going to use 4 and 5.
I used 2, 2, 2, and 5.
Shh. So 5 is prime. I can break down the 4, 2 and 2. So the prime factorization is 2 times 2 times 2 times 2 times 5. That is the prime factorization for 80. I broke it down to all prime numbers. The bigger the problem, more complicated obviously. That the larger the number, more complicated. Marquise, face forward please. Write this down. $53. It's not 2. 5, 6, 7, 8 is the 8 is not divisible by 3. It's number 9. I'll give you a hint. It's prime. Shh. Okay, number 69. 69. Sam, come here. And right there. Okay, these two numbers, if I add the number 6 and the number 9, what does it come out to be? 6 and 9. Comes out to 15. Is 15 divisible by 3?
Yeah.
Yes, so that means that I'm going to try 3. Does 3 go into 69? Yeah, it goes in twice here. That's 6. It goes into 9 3 times. So it's the prime factorization, 3, 23. That's a prime number. And that's a prime number. So the prime factorization for 69 is 3 times 23. The only way we found it was we added the two numbers and equal to a number that's divisible by 3. How about 67? It's not even, so you can't use 2. It doesn't end in 0 or 5, so you can't use 5. Let's try the only other trick we know. Add the two numbers up, see if the numbers are divisible by 3. 7, 8, 9, 10, 11, 12, 13. No. So I'm going to say this is prime. Prime, baby. Okay, 49. Two numbers multiplied together give you 49. 7 and 7. 7 times 7 gives you 49. If we do that, we circle the two 7s. So it's 7 times 7. Don't just put 1 7. There's two of them. So it's 7 times 7. $47. It's not even. Doesn't end in 0 or 5. Does it add up to anything divisible by 3? 7, 8, 9, 10, 11. Nope. So it's prime. Unless there's something yeah, it's prime. 94. Is it even? Yeah, it's even. 94 is even. So we know it's divisible by 2. It might be divisible by something bigger, but let's start with 2 first. 2 prime. 94 divided by 2, that gives me 4. 47. 47. 2 times 47. We had just said that 47 is prime. So the prime factorization is 2 times 47. Two times 47. That's prime factorization. That's the only one number. We took one number and we broke it down to its prime factors using the factor tree. I'm sure you've seen it before. It's called the factor tree. Why does it do that? Okay. Now, the homework for this page, it's 2 through 20, even. This is due on Friday. This is what I'm gonna do. Today I'm gonna assign the front, which we just did, that front side. Now we're gonna do another lesson. Same style, we're gonna do the left, I'm gonna do the right. That one's due on Friday. Tomorrow, you get another one. Friday, you're gonna turn in your notes. You're gonna turn in those 2 sheets of paper. On the top shelf over here, on the top binder over here, not binder, the shelf here. And then when you turn your homework in, then I'll give you the quiz. That way I can grade your stuff real quick as you're taking your quiz. So make sure you have this done by Friday. Yeah, they're the ones I'm going to give you, 2 through 20. Now let's flip the page. Oh. Okay. Now we're going to look at something a little different, but based on prime factorization.
I know this too.
Yeah. But it's just about a matter of making mistakes. Okay. Now we have 2. Stephen, face forward, please. We're looking for the greatest common factor. The greatest common factor is the biggest number, the biggest factor they have in common. It's also known as GCF. GCF, greatest common factor. That is not multiple, that's a factor. So we have these 2 numbers, 5 and 3. What we have to do is factor each of those first. Factor the first one, factor the second one. Circle the ones they have in common. Let's do 15. If we do 15, what are the factors of 15?
5.
And what else?
2,
3 and 5.
1, 5.
Those are prime. We're done with 15. Right? Now the other number is 5. Can we factor 5? It's already prime. So that's a circle. Now the question is, what's the biggest number, all the biggest numbers, that they have the same?
5.
2 5s. So the biggest number they have is 5. It shows up once. So the greatest common factor, this one's 3 times 5. This one's 5. So the greatest common factor is 5. The biggest number that goes into both of them, because 3 does not go into 5. So the biggest number they have together is 5. Number 35. Number 3, 35. 35, we break it down. And Nelson, write this down. Look at the screen, write it down. What are some factors of 35? It ends at 5. 5 and 7. 5 times 7 gives you 35. So you put 5 and you put 7. How about 20? Those are prime. 5 and 7 are prime. 20, what do you break it down into? 4 and 5, because 4 times 5, gentlemen. I've said it before. This is review. This is simple. Many of you mess up, you don't pay attention, forget on the quiz, and then you make simple mistakes. Please don't distract others by you not paying attention. This is 4 and 5. 5 is prime, so I'll circle it. 4 I can break down into 2 and 2. Those are prime. What numbers is it? Well, let's break it down. This is 5 times 7. And this is 2 times 2 times 5. What's the biggest number they have in common? 5. Now they only have one 5 in common. The top one has a 5, the bottom has a 5. If the top one had 2 5s and the bottom had 2 5s, then it'll be 5. It'll be 5 times 5 will be 25. We're going to do one like, I think the next one's like that. This one's easy. At least the 12 is. 3 times 4. So we take 12, break it down to 3 times 4. Very tedious, very straightforward, but easy to make a mistake. 2, 2. Prime factorization, 2, 2, 3 for 12. 2, 2, 3 for 12. Now 44. What's a prime? What's the factorization of 44? It's divisible by 2, but I want something bigger. 11. 11 times 4 gives you 44. You can still do 2. You know, get the same number, but 4 times 11, 11th prime. 2 and 2. 2, 2, 11. Now we're looking at greatest common factor. Well, they have this in common, and they have this in common. So the greatest common factor is 2 times 2. The biggest number they have in common, the top twos, okay, they had 4 together. So the biggest common factor would be 4. 4 would be the biggest number that I can multiply into, divide into 12, and to 44. For this one, I'm going to do 9 first. Because I think 39 is weird. 3 and 3. 3 and 3. 39. It's not even, it's not 0. What's the other trick we know? 9 plus 3 gives us what? Is 12 divisible by 3? Yes, so 39 is divisible by 3. How many times does 3 go into 39? Yeah, go ahead. 3, 13. 3 and 13. 3 is prime. 13 is prime. It's 3 and 3. 3 and 13. Yeah, 3 and 13. 3 times 13 gives you 39. What numbers do they have in common? Well, they have 1, 3. And that's it. The 9 doesn't have 13. So the greatest common factor is 3. People are going to get confused. They're going to put, okay, shh. The greatest common factor is 9 or 6 or something. It's just the numbers that they have, the biggest number they have. Number 9. 22. It's even, so I can divide it by 2. 22 divided by 2. 2 and 11. You could do it off the top of your head. If you divide, you get the same thing. 2 and 11. Both those numbers are prime. So this is 2 and 11. 11 is prime. So it's 1 times 11, but the 1 doesn't really count. So what's the biggest number they have in common?
11.
11.
Shut up.
Almost halfway through. Almost done, almost done, almost done. 35. Shh. It ends in 5. It ends in 5. 35 divided by 5. 5 and 7. Can we break it down any more? Prime and prime. 5 times 7. Now 21. 3 and 7. Prime. So what do they have in common? The biggest. 7. So the greatest common factor is 7. As you can see, although it seems like a lot of problems, when you do them, it should take you less than 5 minutes. Just go down the list and get the answer. Okay. Arteria, come up. On the board, do number 13. Stand there. Number 13. It's just like regular pencil. Okay, she's gonna do number 13. As she's doing it, please do it on your sheet of paper.
Number 13?
Yes, number 13.
Okay.
Is that what we just did? No. Okay. Okay, she's breaking down 30 into 10 and 3.
I'm done.
Break down 10 into 2 and 5.
Shh.
Go ahead and circle them and put them across for the 30. Okay, gentlemen, please follow along. 2, 3, and 5. She's doing exactly how we did it before. 35, how do we break it down? 5 times 7.
Yo, 2, 3,
5 and 7. They have one number in common, 5. Very, very well. Very, very well. Okay. Greatest common factor was 5. The biggest number that goes into both of them. Almost. More keys come up. You're paying very good attention to come up. To number 15. Okay, last one, 15. Marquis going to do 15. Take the 14 and break it down. So put 14 on the side. Steven. Face forward. That's good. Perfect. What two numbers go into 14? Multiplied.
2.
2 and what?
12.
7. That's 2 times 7.
I know. You said 7?
7. Okay, listen up.
I did have to say that.
He did 2, 7. Marquis, circle them. Those are the two numbers that go into 14 multiplied together. Circle them individually. That's fine. Now put 2 times 7 across the 14. Okay. 42. Help him out. Raise your hand. Tell me your factors of 42. 7 and 6. Take the 42, put to the arrows.
7 and 6.
7 and 6. Can we break down 6?
2.
2 and 3. And 7 is prime. So circle 7, the 2, and the 3.
7, 2, 3.
And now multiply those out. 2 times 3 times 7. Oops. Wait. Go ahead.
Put 2, 3, and 7.
2 times 3 times 7. Little dot. 2 dot 3 dot 7. Okay.
Great. Okay.
What numbers do they have in common? Well, they have the 2. Circle the 2. Top and bottom. And they have a 7. Circle the 7 on the top and bottom. So the greatest common factor, put GCF. Shh. Greatest common factor, 2 times 7. What is 2 times 7? 14. So right there, put 14.
Well, you can't just say one word. Man, put it to my friend. You said bend down.
As I mentioned before,
You want to see bend over.
ladies and gentlemen,
I know. Me saying that. I was bending over.
I tried to be not mean. This is being recorded. I've told you 1,000 times it's being recorded. And certain people, especially in the front, get caught on tape. Somebody else is doing it, stay quiet. If you want to help them, raise your hand. But this right here shows up on the tape. And then it gets put on the internet. Please keep your nose down. Okay, your homework for this section is 2 through 16 even. This is due on Friday. No.